Hello, everybody. Are you interested in self-autonomous AI agents or swarm intelligence? Interested to see some architecture that could potentially get that done, where we discuss swarms and want to look at some code to make that happen? Well, you're in the right place. Stick around. My name's Alex. I'm from Aspen AI, and let's dive right in. So recently, we had a pretty big announcement from OpenAI regarding the new feature drops. So on their Dev Day, they made an announcement about GPT-4 Turbo and increasing the prompt context window to 128K. It's amazing. It's about 300 pages of text, which is huge, just per prompt. They came out with a new Assistance API, which also they called it their own like private GPTs, and so GPT-4 Turbo with Vision came out. Additional features for Dolly 3 in the API to be able to connect there, and a lot more. So yeah, a lot of really cool updates. One of them, of course, is the Assistance API. It's going to allow developers to build AI assistants within their own applications. So really cool for certain tools tailored towards maybe the market, which doesn't really mind having a lot of their data integrated with OpenAI, but a fantastic capability that's been added to their package. Along with that, in on the more on the consumer side, they came up with this GPTs, and you could create custom versions of Chat GPT. So this is the consumer side, or on the Chat OpenAI side, you're able to use these GPTs, and from the developer perspective, you're able to use the API to come up with these custom Chat GPTs that use your documentation as an external source of knowledge, and then you can pre-prompt various skills. Also, in combination with Zapier, you can create really cool workflows and automated workflows for, again, some of the small business and no code applications, where you can link now these assistants and the GPTs with a bunch of different zaps to get a lot of cool workflows completed. Now, what is this resting upon, and how are we able to kind of manage and get these things done? Well, it seems like there is definitely a push going towards having these agents rely on some type of a cognitive architecture or their own brain to get things done as they encounter different challenges out in the real world per se. And so the fellows here at the Princeton University recently released in September this cognitive architecture for language agents, or what they call as Koala. I'm not going to go too deep into it, but it's a really interesting and fascinating way on how to add, you can kind of cognitive abilities, reasoning abilities, and memory to our agent frameworks in order to be able to not just interact with a set of documents and an environment, but also be able to update memory via reasoning loops that come to certain conclusions and constantly update information throughout the loop. So the sex architecture relies heavily on work done previously, determining various ways that memory can interact within an agent framework, where we can have procedural, semantic, and episodic memory work in conjunction with symbolic working memory, where the agents are able to figure out different paths along the way and different solutions along the way using code or predetermined set of documents or information, and then the history of all of the interactions in the episodic side. So on top, the symbolic working memory uses the longer term information stores along with feedback from the environment, spatial visual systems, other perception, in order to do what resembles to be cognitive abilities. So you can see that we've progressed from the way that we've been interacting with models. So, and we've been controlling them via prompts. So now the flow itself has been significantly improved upon from what was initially where we thought that the LLMs would be doing all of our reasoning and all of our meaning LLM, like a one large GPT-4 would handle absolutely everything and then give us an output in full completed mode. Well, that's not the case. So this is the reason why we need chains and agents in order to interact with themselves and have an internal loop that optimizes the output before the user actually sees anything. So this is kind of, you can see an application of that where we have procedural memory, semantic, and episodic memory, and that is put into a working memory, and the working memory has workflows that improve the reasoning along the way. And the same thing can be said for each of the different memory modules, where they also have self-improving workflows, and all of that then interacts with the user in the physical world, digital world, and then via the user with actually through like a chat session. All right, a little bit more into what exactly is memory, and this very simple the chart will show you. We have an initial question. That question gets put into what would be traditional LLM workflow, where we have a prompt, we send it to the LLM, and then clean it up through the output parser, and then we have an answer. That answer is loaded and stored in memory, create a past messages database, and the next question the user asks, it combines together with some sense of the past messages, and then continues the loop by pushing now the past messages in the question further on. A really clever, fantastic implementation of this is MemGPT, where you can create perpetual chatbots with self-editing memory. So this is a advanced, really nice version of, or implementation of, this very simple kind of memory management. So with MemGPT, you're able to create perpetual chatbots, right? And because MemGPT is able to create and store and manage long-term memory of the LLM, so you can have almost an autonomous chatbot due to that. Another very good implication or implementation of that is from Plastic Labs with their Tutor GPT, and they combine human, machine, and learning all together, and they open source their Bloombot, and their Bloombot pretty much handles this type of cognitive reasoning by taking the user's prompt, putting in into a chain that determines and improves the thought on that user's input, and based on their predictions, they update the prompt body and then give a much better cognitive response. And every time this loop is completed, the response is always updated with additional predictive reasoning in order to be able to optimize and anticipate better what the user might be saying next. So you can see that they implemented this in their Bloombot, and in this diagram, you can tell that there's an initial question on an app or in the Discord. There's the initial user input, and it starts with the initial chain. And gives, in essence, a conversation starter. But the next chain gets a thought, additional thought added to the input, and through processing in the back and using conversational summary memory, you're able to combine various reasoning workflows to the actual response, so that when you're sending now the response over to the human to past your chain, it's now including various thought improvements and optimizations as to what it thought would be a better way to ask the question, analyze certain parts of the question, then give an answer, analyze if that answer is good enough. And so you can run through various chains before you give output to the user in order to optimize the output. And you do that very well with the conversation summary buffer. That's what was mentioned in the list for Bloombot, and you can see the details. This is a LangChain implementation. It keeps a buffer of recent interactions in memory, but then rather than just completely flushing all interaction, it compiles them all into a summary and uses them both. So very clever interaction. then MetaGPT. It's another fascinating layer on top of it all, where it's a multi-agent framework, right? This allows the software assigns different roles to GPTs to form a collaborative software entity for complex tasks. So think we now have the various GPTs that we can make, and we can combine all the different roles in order to come up with a collaboration between them all. So in this case, we're in the MetaGPT original use case was that we're creating a software company, and the code itself is able to produce a mimicry of a software company, and it realizes that the company needs a boss, a product manager, and then can deduce all of the different roles, that each of those positions would do. Now, after rolling that out, you can see that virtual company is able to create virtual content, feedback, have a recommender mechanism, a user mechanism. So what we have is we have the ability to have MetaGPT roll out multiple GPTs that utilize advanced memory modules to come up with all of these different schemas that can then be used throughout the agent swarm or the agent process. And the way that we would be handling that is through this architecture, where we have a data store with a memory layer, so our traditional SQL vector database or document and links, and they interact with the memory modules interact with the data. And you see we have at the bottom here the procedural memory, semantic, episodic, and predictive memory, and more higher form of memory of where we do collaborative memory module, memory consolidation and forgetting, which is going to be an important, almost kind of like simulating the brain's sleep cycle. We're going to have to forget certain things as well. So algorithms that would get rid of various information from SQL vector that isn't really relevant or necessary. So from the memory layer, we move over into the abstract layer that I can call the agencies, and the agencies contain various forms of agents that combine together form really kind of like a logical set or logical group that would handle data collection, user acquisition, cross-platform synergy, governance, and also build toolkits. So an agency that is in essence contains all the various agents that could be deployed to build tools themselves and agents themselves. So we have various agents within the agencies that can be put together that do news aggregation, content optimization, user interaction. We have LLM fine-tuning agents, self-replicating agents. So the agencies be able to organize and deploy various functional agents that then use various tools that help the agent complete some task. And it could be search tools, SQL code, and tools that are self-replicate, and agents that can create additional tools would be also an important part. And then the tools and the agents and the tools also use prompts, and then we can have tools then create prompts as well. So on top of the prompts, we have the various prompts creating the actual content. Then we deploy the content to some platform, and then we have a user interface UX layer where we either use a web app or a chatbot or a mobile app to interact with the system. Then all of this is handled by core controllers that manage each of these layers and combinations of these layers. And then we have what I call nano auto-tuned LLMs. So micro LLMs that handle all of the different steps and processes, or each of the steps and each of the workflows. They call a very specific LLM that is designed to handle like a very specific set of functions. Database query optimized, LLM that is specifically optimized for vector indexing, memory module management, selections, so agency selection, tool selection optimized, various LLMs that have been nano auto-tuned, and I'll show you what I mean by auto-tune. Now, how do we get all this working together and being controlled? Well, you're going to need some kind of an intelligence core. And what is the core? Well, the core is going to be the command and control structure, right, of our swarm. We need the main intelligent core in order to deal with all of the data that's going to be distributed amongst all the agents. We're going to need, the intelligence core is going to need to apply a process called stigmergy, a very interesting concept that relates heavily to nature, where, and we'll go a little bit deeper, but where creatures and elements leave certain traces or signals in an environment for others to pick up, oftentimes pheromones. So you can see how bees and certain like funguses are able to communicate with each other by leaving traces in their environment. So this is going to be a very important and interesting concept that is going to have to be applied, I feel. And so we're going to need to also do self-organization. We're going to have to handle the adaptive clustering and the consensus decision making amongst all of the different agents. And altogether, all of this is going to be done in a way with assistance from stigmergy. So stigmergy, again, what is that? It's a communication through the digital environment, all right, where agents, they're going to leave markers and respond to informational traces. It's a mechanism of indirect coordination, right? So action stimulates the performance of a subsequent action. And the way that we can manifest this is through, again, the modification of a shared environment that informs the behavior of other agents. And when one agent updates the environment, that acts as a stimulant for another agent to do some type of action. So it's digital markers, and we can have these digital markers have different intensities or different lifespans. In essence, it put in some decay rates. They're able to monitor the changes in the environment. So agents that are going to be able to see and sense what is happening based on these signals. And because of that, that could lead to all kinds of different feedback loops and allowing the agents to select the tests dynamically. And this environment itself is going to need to be, there's going to need to be some kind of a signal space where all the agents that need to be very comfortable and confident that this information there is real, which is potentially could introduce some blockchain tech. And yeah, so various ways to implement all of this stigmergy, different type of like pheromone-like systems for the agents to understand what they're doing and where they are at. How can we implement this? Well, one framework that I've been working on and conceptualizing is NanoGPT. So NanoGPT is a framework where it has the swarm intelligence core that handles all of our different controllers, provides the central signal space. Then that core is able to deploy various agencies that interact or are controlled in some way through user interfaces. And those agencies then deploy agent swarms, self-autonomous, self-controlled agent swarms that are able to interact with the internet, intranet, dark web, and all of the different content hubs out there, and come out there, understand what's going on, and start to produce content and start to produce results based on their discovery. So let's take a look at some of the fundamental principles of the core and how that might play out, right? So we have different core controllers that interact with a single shared signal space, with a central shared signal space, as well as each other. So we'll have cores that manage the different agencies, Oracle that provides various type of supporting analysis, the various different signals or pheromones, and the controller for that, the controller for all of the nano LLMs, and to be able to auto-tune and fine-tune those, the memory core controllers, the executives that specify actions, to-dos, and priorities, and the optimization core that optimizes based on various templates like SEO, code, or A/B testing. Now, what's going on here? So we have an agency manager, and the agency manager will contain various agent types. And what are agents. Agents, what kind of types do we have? Well, we can have like a scout agent, a creator agent, an optimizer, a distributor, an analyst, executive, an oracle, various type of agent types. And the agents will have a certain set of properties, and like a template ID, agent type, initial behaviors. We can set the search depth, content scope. So various types of data structures for various types of agent types. And so this agency core will control that. And Oracle will have the various protocols, a constitution, a contradictor, a rogue agent that tries to break things and allows the system to self-heal in some way. We have the optimization core that will go through various loops and workflow loops that will update our prompts, update our knowledge. And you can see that we have a task or a chat. We'll have a prediction, a comparison, and a learning chain. Each one of those have their own nano LLM that can be applied. And then another workflow that we'll add on top of that, which will come up with data sets to normalize and to auto-tune these nano LLMs as the need arises, as certain agents will determine that there is now a significant need to improve the functionality or potential to improve certain cognitive abilities and of various stages here by updating the LLM with new information. So the optimization core handles all of that. We have, of course, the memory core, and that deals with all of our various memory forms. And then the signal space, the very interesting central signal space that all of these different elements and the agents themselves leave artifacts in the shared signal space. And the signals have various characteristics like the type, intensity, decay rate, timestamp, metadata, and each one of them will have that data scheme. And so you can see how we can come up with various signals that if you were to use an analogy here of the thickness of the border, the intensity of the color, and as the signal diminishes, you can see that the color lessens, the border reduces in thickness, and so the signal itself starts to disappear. So the bigger the signal and the stronger various elements of that signal, this is how our agents are going to interact and discover where the focus needs to be. And so here we can see that the signals themselves have all kinds of different qualities and descriptions that we can apply, and different types of indexes that we can apply to improve the interaction with all of the signals. So we have this central core, and the central core then deploys all kinds of different agency templates. They'll have agent replicators, LLM auto-tuning, the content agencies, the toolkits. All of this is managed in some way by a user interface of various forms. And this area actually has a huge room for innovation as to how do we now interact with these different swarms. So as we saw, there's different type of agent types. We got the scout, we got the content creator, engagement optimizer, oracle, executive. And from the agency template, we then get a deployment of a swarm. And what does a swarm consist of? Well, a swarm will have a executive that is able to delegate, an oracle that consults, all right? And then we have the engagement modules. We have the scout up front. We have the content creator. We have the analysis modules. We have the various distributor agents that are able to figure what's the most optimal time and platform to put the content out. And then the engagement module, which interacts with all of the users. All that is handled by all of the different auto-tuned nano LLMs that have a process where they normalize the data and goes back to, so what would that look like? Well, we have a delegation to the scout up front to scan and identify something. Once the scouts identify, they give information as to what kind of content would be really good and optimal. The creation modules then go into work and start to create the content. The analysis runs consistently on all of the interactions and all of the different functions to see if anything can be improved, and so on. So you see how that swarm gets then deployed over to a particular asset. And so if we were to find YouTube, for example, here we have already a swarm that has sent out a bunch of agents, a bunch of a bunch of scouts to find and discover what had to happen. Then the scouts call over the content creators. The content creators start to call their own executives, and the executives start to offer them what to do with the help of the Oracle analysis. And you can start to really almost kind of like a cell, start to combine various forms and various methods and the way that they interact with each other. Is going to be very interesting, because I have a feeling that there's going to be some emergent technology or emergent effect coming out of that we have a hard time predicting. So these swarms deploy out to the various content hubs, are able to figure out what are, for example, the most viral things or the most interesting things going on, and then start to act and activate different type of workflows and different flows for the additional sub agents and sub agencies that then can interact with that content or publish that content. So as you can see, we do have the groundwork and all of the fundamental things necessary in order to come up with self-autonomous agent swarms. So when you think of that, I'm pretty sure, like in my mind, it comes up with something like scary that could resemble something like this, right? Like or this even, right? But it's that not scary, or this is really frightening. Like is this what we're going to? I think it's going to be even worse. It's going to be even more frightening. It's going to be something like this, and like this. Okay. So let's see, how can we get that done? How can we achieve some of this in a practical sense? Well, let's look at LangChain. Let's quick reminder of what is LangChain. Well, LangChain is this really awesome framework where it's a bunch of wrappers for functionality to make calls to the LLMs, to initiate tools, to create agents, and do some really cool advanced stuff with it. So you can see all the different layers that they have here for LangChain. And what really we're trying to do is we're trying to create these flexible conversation patterns with various robots and various bots interacting within one another. And so we can actually do that and implement that. Now you can implement that, of course, with the Assistance API, where you give OpenAI all your data and all of the processing, and they just do it all for you. That's awesome. And then you'll get like cool things like apologies for inconveniences, but the files are not accessible, blah blah blah. So brilliant. But if you really want to get it done and make it work, we got to take a look at the agents from LangChain. And LangChain agents are awesome. What are they? They're various different types of agents that we can implement. We can take a look at actually all of this cool stuff that we can do with agents, like use toolkits with OpenAI functions, access intermediate steps, create custom agents, custom agent with tool retrievals. So very important, very interesting. How can we do this? Let's take a look. Let's take a look at an agent swarm in LangChain. All right, let's see what that would look like. But first, we install all the necessary things. We set up our API keys here. And now we're loading all of the different LangChain models, like the chat models, the agents, the various tools, and then different utilities like the DALL-E image generator. We're going to import some prompts as a prompt template, and then our chains. So we go down, we designate our LLM here as GPT-4. We set the temperature. Now we specify the tools. Now one way to load tools is like this, where we specify various tools in our toolkit. And the tools have a name, a function, and a description. Very important. These LLMs will be able to use these descriptions to figure out what tools to use along the way. And here's the different functions, how I actually get them to run. Another way to do it, and more of a new way to do it, is we specify the toolkits, and then we just load the tools into that toolkit. In our case here, we're going to be using Search API, DALL-E image generator, and then we specify the LLM that we defined earlier. And then we define an agent by initializing, calling this initialize agent class, then we specify the tools that we define, the LLM, and the agent type, as I showed you, the various types of agents that we can use here. We specify the agent type, we set verbose to true, and then early stopping method. And really what that means is that it does one final pass through the LLM to generate the output. You can also use force if that's just to return the full string. So we then run our agent here, and we pipe this into an output. And I asked it, what is the price of Bitcoin? Summarize any recent news about Romania. Give me a photo of Bitcoin with a rocket flying by on the way to the moon. And what's the temperature in Switzerland? Okay. And if we take a look at the actual chain, so we enter the new executor chain, and then it needs to gather information about the price of Bitcoin. Here's its action is going to be using the search API, and its input is the price of Bitcoin that it determines. So the observation is quite complete and very well done. So it finished that process, and now it goes, okay, I've gathered that information. Let's continue on. Use search to find recent news about Romania. All right, so there's our observations. NATO member Romania finds more drone fragments. Ukraine Zelensky visits neighbor in Romania. And the worst news of it all, that Tonga ends the Rugby World Cup with win against Romania. Dang it. Then additional thoughts. So it gathered the information and moves on and says, hey, here's the image of the rocket flying on the moon. Okay, sure. You can do better, Dolly. But there it is. And then it moves on to the temperature in Switzerland and gives us that. So the final answer looks like this at the end of the chain. So we got the price of Bitcoin, recent news, a photo of Bitcoin, and the temperature in Switzerland. So it finishes the chain. Fantastic. And gives us this output. If we want to then process in any way we wish, or push this into a second agent as the input, right? So all kinds of cool things that could be done then. Now, let's go through and try this in another way. How would we do this? Well, we're going to import OpenAI chat prompt templates, and a string output parser to clean things up. So we designate two prompts, right? And create two prompt templates. What is the city a variable person is from, right? So what city is a person from? And then the second prompt is, what country is the city in? And please respond in language. So we're going to have prompt 1 determine the city for whatever person we specify. And then prompt 2 is going to determine the country based on the city that is determined in prompt 1. And then it's going to respond in a language. So you can see how we can chain a bunch of different things together. We designate our model here, chain OpenAI, and then we create our first chain, which is easily done with a prompt, a pipe into a model, and then a pipe, which is what this character is, into the standard output parser. Then we have chain 2, and chain 2 uses chain 1 to determine the city, and then a item getter function to then pick out the language. And so it pipes that again into prompt 2, model, and standard output parser. So now we run the second chain. We specify that our person is going to be Trump, and our language is going to be French, and then whatever this is in French is the output. But it does look like it says it's the 45th president, and then other funny words. So now let's try something more interesting, right? Something like we have 1, 2, 3, 4 prompts. Okay, so this prompt is going to design a color palette for digital artwork and return a hexadecimal code for the color. So we give it an attribute, and it gives us a color palette. So an attribute would be potentially like warm, cold, or anything else. Or even the color itself. You just give it that. But what is a character or mascot that represent a brand with the primary color that we will actually return here? And then it's going to return a brief description, right? Character description and nothing else. And so now we're going to create a concept for that logo. we're going to draft a brief for a digital advertisement campaign featuring a character that is created based on all of the stuff prior. So we push it through our create a model parser here, and this is where we put in our model again through the standard output parser. So and then we do our color palette generator, and here's our chain where we create all of the different colors and define the different colors. Then we create a character generator chain, and then we have a logo concept generator. And so you can see it pipes through all of the different prompts, all the different chains in order to come up with, let's see, a campaign brief generator. So it's going to be using, I gave it input of blue, and then we invoke the model and look at the AI reply. So we have dive into fun with Splash, a digital advertisement campaign. The objective of this digital advertisement campaign is to promote water-related activities. All right. And through the friendly, energetic character of Splash, a sleek and vibrant blue dolphin. So that gives us like what the campaign is supposed to do. So we're target audience and all kinds of cool other elements, as you can see, about what the campaign should be. Different shades of blue will evoke feelings of depth, tranquility. So it does a pretty interesting analysis. Now, merging multiple streams. Things are getting spicy. All right, so what do we got here? We got a planner. We got a arguments for. So we define a planner. We define argument for and argument against bot. So here we have a planner which is going to generate an argument about a certain subject and create a response. So then we take that response and we say, okay, here's the arguments for our base response, but also here's the arguments against our base response, and now pipe them both and combine them both together to generate a final response given the criticism. Really cool. So then we create a chain with our planner and do results 1, results 2, original response, and then we get the final response. So in this case, we invoke the chain. My input is Bitcoin, and here's our summary of basically it takes like the cons, the pros, and then combines them all together. And you can see, if you pause this, you can take a look and see that it's actually really good, because it does go, while has the potential to revolutionize the financial industry and become the future of currency, of course, but it's also crucial to acknowledge the cons and potential challenges, the volatility, lack of regulation, scalability, energy consumption, limited acceptance. Very interesting how it did that. So you see how it just combined it all into a really interesting summary based on what the various bots compiled on their own. All right. Oh, goodness. So one quick last way to take a look at this, and even more fascinating way, is we go into Autogen. And Autogen, we can create a group chat from various different agents. So here we import our Autogen, set up our configuration, which requires this config list file .env to be created here in the file section. Now let's get a swarm going. So here we designate an agent proxy. It's going to be an AI agent that is the admin and the task coordinator. We designate, now we're starting to get into the actual swarm defined. So I came up with a scout, a creator, an optimizer, an analyst, an executive boss, and an oracle. As you can see, the different prompts that they have here, their system messages is review and optimize the content. For the boss, for executive boss, evaluate oracle, agent suggestions, and all agent discussions, make strategic decisions. So all combined together, we put that into a group chat and then run the actual chat from the different agents. What's our input? Well, create and optimize a clever and unique marketing campaign for my AI development business called Aspen AI. Okay, so simple, and here we go. What does that look like? Well, in the beginning, let's scroll all the way to the top just so that it'll save time. We set up the initial prompt, which is create and optimize a clever marketing campaign. And now the scout goes, okay, the initial name is Aspen AI, unleashing the future today. And so it gives us a style, a voice, and a form. Now the content agent goes, okay, campaign name, unleashing the future today, and now creates a blog post, creates a social media content, some webinar marketing message, and various other messages here. The optimizer now, this is where it gets interesting. So the campaign one said, fine, I'll just create a campaign unleashing the future today. The optimizer decided that Aspen AI, pioneering tomorrow's AI today. And then it did an optimization of each of the content that was created earlier. So analyst now goes, here's some actionable insights after the optimizer took care of it. And so it gives each of the areas some insight. Oracle then takes that from the analyst and suggests various forms of action. And the boss says, okay, here are the strategic decisions for all of you. Scout, content, optimizer, analyst, start doing these things. Remember, communication is key. Keep things updated. And they all go, understood, boss. I'll start researching. All right, good stuff. So great. Everybody's clear. It gives them an update. Now I got into this like fascinating loop that I might have to change the prompts to get out of, is that they keep patting each other on the back. Saying, excellent. You guys are going to do all, they're like, understood. We'll do all this. And the boss says, excellent. I'm glad to see everyone's on the same page. And then here's more stuff. And now they go, understood. So I'm curious if they're just going to get into a loop of like, good job, understood, good job, understood. Let's see. Another way to apply this is a research swarm, right? So what would a research swarm look like? Well, we set up our configuration here. We can specify a seed, and the seed is basically changes the output every time you run it. Then we designate an admin, right? Interacts with a planner to discuss the plan. Plan execution is needed. Then we have an engineer. It follows the approved plan. It writes Python shellcode, right? Interesting. There's a scientist that follows an approved plan. There's a planner, suggests the plan. And there's an executor, a critic. And what we're trying to do is find papers on generative AI from archive, I don't know how you say that, in the last week, and create a markdown table of different domains. So what that would look like is something like this, is that the agents start finding papers. So the planner gives engineer descriptions of what to do, scientists write, engineer write, review the markdown. And so as you see, then it goes through the critic, provides the feedback, goes to the engineer, and they are actually able to generate some very interesting output together, where they come up with the code necessary to do this. And after they've done that, they're actually able to retrieve all of the different titles from archive. Fully quantum auto-encoding of 3D point clouds. All right. Fantastic. So one last way to do this is we initiate another group chat here, and let's take a look at what to do here. So here, this is an interesting approach where multiple agents are able to handle communication amongst themselves to get a job done with limited amount of information for everybody. So let's take a look at this last case where we have agents in group A and we have agents in group B. So agents in A have a leader and they have team members. So team member 1 has a secret knowledge of X but not Y. And team member 2 has the knowledge of Y but not X. This team, team B, it is important to find out the value of X, Y, and compute. So B member is going to be computing the value of X and Y, but we don't know that. This team doesn't know that. So the leader of B needs to communicate with the leader of A and cannot communicate with any of the members. So the leader has to then communicate with the members in order to get both the values and pass it on to the different team, which is super fascinating. Super fascinating. So the group chat is everybody cooperate and help Agent B in this task. Team A has A1, A2, and 3. Team B, so we designate the teams and we specify what it is that you need to do. We give it a 30 rounds that it can go through, and then say, okay, we need to find the product XY, and other agents know that. So what does that look like? Well, find the product. So B2 says the other. So this is our initial request. So B1 to chat messenger, can you please provide the values of X and Y that your team members A2 and A3 know? We need them to find the product. And sure, let me check with my team members. A2, A3, can you please provide the values? A2 gives X, A3 gives Y, and then the combination is multiplied. And then B says, thank you, we got it, and it's done. So how fascinating, how interesting. And we're going to dive a lot more into all this. So I just wanted to show you guys this fundamental, this baseline way of getting these things done. And in the next set of videos, we're going to be able to come up with custom agents that do custom tools and start to discover and run their environment and their world more autonomously. So I'll end it on that. If you have any questions, anything about LLMs, or have any interesting projects that you want to discuss, reach out to me on Aspen AI. Thank you guys very much. We'll see you at the next video.